Okay, so welcome to the second part of the video, and this time we will be dealing with or focusing our attention on scientific notation. And so all we have with scientific notation is a way of writing very large numbers or very small numbers so that they're in a form that's workable. And so you can see in our example over here, we've got the number 2 million. That written in scientific notation would be 2 times 10 to the power of 6. The way that we would do that is we have a decimal point here, and for each, essentially there are two rules. Numbers in scientific notation are written in the form of c times 10 to the power of n, and what we mean by that is c over here, the number in the front, which is called the mantissa. This number must be between 1 and 10, including the number 1 but not including the number 10. And what we're basically going to do is write it as a number between 1 and 10 multiplied by a power of 10. And the reason we use a power of 10 is, of course, because we're using the metric system, and each of our decimal places is a multiple or power of 10. And so basically what we're going to do with this number here is take our decimal point. We're going to have to move that 1, 2, 3, 4, 5, 6 times in order to get a number between 1 and 10, and that's why we write it as 2 multiplied by 10 to the power of 6, 6 accounting for the fact that we moved our decimal point 6 times in order to reduce the number 2 million to the number 2. If we had the opposite, as in taking a number which is a decimal and attempting to write that in scientific notation, then what you can see from the example below is that our exponent for 10 is a negative, which implies a fraction, which implies division, and ultimately that allows us to know that that in fact is going to be a minutely small number. Once again, the protocol is the same. We have our decimal point. In order to get a number between 1 and 10, we move that 3 places to the right, and so that matches the number 3, and we make it negative, which indicates that the original number that we started with was in fact a decimal number, or rather a number which is between 0 and 1. Okay? And so what we're going to do is we're going to go right ahead and we'll move into the examples. Two different kinds of examples. The first kind are ones that can be done on the calculator, and I'm going to show you how to do those on the calculator. And then examples 5 and 6 will involve questions that are done without the use of the calculator, and essentially these are the ones that you need the understanding of what scientific notation is in order to be able to answer them. So let's start with those, and after that we'll turn our attention to how to do these on the calculator. So we'll work backwards this time. So I'm going to start with example 6. Without using your calculator, we're going to write each of these two numbers in scientific notation. And so remember, for scientific notation, the mantissa, the first term in the product of terms, must be a number between 1 and 10. And so essentially what I'm targeting here is the number 4.35, and I need to move this decimal point a certain number of places until I reach where I've put my purple decimal point, and that will allow me to write the number, or rather have the mantissa, the first term of the product, to be between 1 and 10. So here I have to move 1, 2, 3, 4, 5 places, and so to write that in scientific notation, I have 4.35 multiplied by 10 to the power of 5, indicating that I moved 5 places, negative indicating that I had a number between 0 and 1. In other words, I had a very small decimal, and the -5 indicates that I moved the decimal point to the right in order to get that into scientific notation. Okay, similar approach in this case. the number that I'm after is going to be 3.75. The decimal place is after the last zero, and what I need to do is count the number of places to the left that I have to move the decimal point in order to get to the number 3.75. So we have 1, 2, 3, 4, 5, 6, 7, 8 places, and so 3.75 multiplied by 10 to the power of 8. This time, of course, I leave it as a positive because my number to begin with was not a decimal between 0, or not a number between 0 and 1. So that's how you write numbers in scientific notation. And what we're going to do as we back up to example 5 is just show a small extension or application of this. And so what we've been asked to do without the calculator again is to place these numbers in order from smallest to largest. And so the first thing that I want to do is either convert all of them to scientific notation or all of them to what is known as standard form. And so we can do either of those. I'm going to convert them all to standard form, but of course we could also convert to scientific notation. In this particular case, in order to convert this to standard form, since I'm multiplying by 10 to the power of 4, I'm going to take the number 3401, and I had a decimal point here, and I'm going to move that 1, 2, 3, 4 places to the right, insert a 0, and that number is in fact the number 34,010. Similarly, I'm going to take the number 2.7 times 10 to the power of 5, so I have 27, and I'm going to move the decimal point from between the 2 and the 7, 1, 2, 3, 4, 5 places, and I'm going to fill in zeros in the space in between, and hopefully you can see we have 270,000, 34,010, 27,500. So in order from least to greatest, 27,500 is the smallest. Then we have 34,010, and the largest of the numbers is 270,000. Okay, if we were using scientific notation instead, we could have rewritten 27,500 instead by taking the decimal point here, moving it 1, 2, 3, 4, and we could have written that number as 2.75 times 10 to the power of 4, and then very easy in this form as well to compare which is the smallest and the largest. The 2 with the power of 4 are obviously going to be smaller than the number with the power of 5, and then 3.401 is bigger than 2.75, and so we could have used scientific notation instead. Okay, and then the last little piece is how to do scientific notation on the calculator. And so what we're going to do is turn our attention now to the calculator. I'm just going to shrink the screen down a little bit so that I'm able to see the calculator and work on the calculator. So what we're being asked to do here, let me make that a little bit larger. What we're being asked to do here is to evaluate each of these expressions and to write our answers in scientific notation. And so that we're going to do by using our TI-Nspire. Okay, and so let me just close that up. That's not what we wanted. Okay, so if I go to the calculator now, the key, most important button on the calculator when working with scientific notation is this button down here, the double E, and that's a shortcut keypad way of using scientific notation. And so what I have here to start on the left is simply the product of two numbers in scientific notation, and as you can see here, the answer needs to be in scientific notation as well. And so I'm going to go to my calculator and simply type in 1.1 times 10 to the power of 7 can be done using the 10 to the x button, but what we want to do is to make sure that the calculator is operating as if these are numbers in scientific notation, and so we use the double E button. That stands for times 10 to the power of, but it essentially tells the calculator that we are working in scientific notation. And so I'm going to type in 7, 1.1E7. I'm going to be multiplying that by 4.2E2. Hit enter, and as you can see, it gives us our answer. Now, what you can see from this is that it gives you the answer in standard form. Our instruction required that our answers were in scientific notation. So one of the things you can do in the calculator is go in to the home page, go to the settings, go to the document settings, and you can see the third option down is exponential format. You can change that into scientific, make that into the default, and then when we go back to our calculate page, what I can do is re-enter that sum, and this time what it's going to do is keep the answers in scientific notation form. Now you'll find that it does this sometimes if you're not in scientific mode. Some of the times it will give the answer in scientific notation, others it won't. It all depends on the size of the answer. And so if we want it to always give answers in scientific notation, we need to put it into scientific mode. So I've typed the same answer, the same question in, and this time you can see it's given the same answer, but this time in scientific notation. And so our answer, 4.62 times 10 to the power of 9. Okay, of course, knowing what you know about the laws of exponents, you could have also done part of this manually. We could have done 1.1 times 4.2, which gives us 4.62, and we should know from our laws of exponents, 10 to the power of 7 times 10 to the power of 2. If we add those powers, that's where we get the 9. Okay, so I'll do the last two examples. Since I'm in scientific notation, it should be relatively easy. I'm going to open a set of parentheses here because it's being squared. 4.3e to the negative 5. Go outside, and what I want to do is raise that to the power of 2. So I'm going to use the little cap button over here, the upside down V. That gives me an exponent to the power of 2. Hit enter, and that is going to give me my answer in scientific notation. So 1.849 times 10 to the power of minus 9. And last but not least, I have a division problem. Again, you don't need to worry too much about the parentheses here because the calculator is programmed to recognize, so to speak, the scientific notation. And so I have 4.5e to the 5, 4.5 times 10 to the 5 divided by 1.5e to the negative 2, and my answer, 3e to the 7, or 3 times 10 to the power of 7. Of course, those have been combined. 5 minus minus 2 confirms my exponent is 7. Okay, and so once you have made a note of those, do turn your attention, as usual, to the level 2 assignment.